Alright, so today's class we are going to use our sine ratios, our trig ratios to figure out the missing sides in triangles. So if we take a look at our first triangle here, we're trying to figure out the missing side x in this triangle. And we cannot use the Pythagorean theorem. To use the Pythagorean theorem, you need to have at least two sides to figure out the third side. So here we're only given one side, but we do have the angles given, so we have to use what's given to figure out side x in this right triangle. So I'm just going to put here our SOHCAHTOA just to remind us of our trig ratios. So S is for sine, which is opposite over hypotenuse. C is for cosine, which is adjacent over hypotenuse, and T is for tangent, which is opposite over adjacent. All right, so we have to figure out which of these ratios will help us to determine what the side x is. So let's start by putting all our ratios here. So sine, and we'll use sine of 20. So sine of 20 is opposite over hypotenuse. Opposite is our 9 centimeters. So right opposite from 20 degrees is 9 centimeters. And our hypotenuse is what we're trying to find. So x. So we can see here that we have enough information to solve for x using our sine 20 ratio. So let's continue then. Our sine 20 ratio you can figure out by using the chart that's given to you. This is in your modules, it's 8.2. So sine of 20 degrees, so we're just going to use our chart here. You're going to go to 20 degrees, which is down here, and the sine value for 20 degrees is 0.3420. So we get 0.3420 is equal to 9 over x. All right, you can also use your calculator to figure out that sine of 20. So I'm just going to show that here. Okay, so we're just going to type in sine of 20 is equal to 0.3420. All right, now we just have to use algebra or cross multiplication to figure out x. So x will be equal to 9 divided by 0.3420. All right, so you can use cross multiplication. You can pretend that this is over 1. So 1 times 9 divided by 0.3420 will give us x. All right, so put that into your calculator and we get 26.316 centimeters. All right, so we've solved for x. Now, we could have also used this angle here as well, 70 degrees, and we could have used our cosine of 70 degrees to solve for this as well. So I'm just going to use that ratio over here, the cosine of 70 degrees, which is adjacent over hypotenuse. All right, so adjacent to 70 degrees is the 9 centimeters, and our hypotenuse is still x. Okay, so now you could use your chart to figure out what cosine of 70 degrees is. All right, so here is our chart, and here is 70 degrees. Cosine of 70 degrees, we can see is the same value, which was the same as sine of 20 degrees, 0.3420. 0.3420 equal to 9 over x, and solving it the same way, x is equal to 26.316 centimeters. All right, so in this triangle, we could have used either sine of 20 or cosine of 70 to figure out side x. All right, so let's take a look at this next example. So we have a triangle here, and we are given one side, 25 centimeters, and we're missing two sides here, A and C, and we're given one angle, 65 degrees. So the question asks us to find side A. So let's start by writing out our SOHCAHTOA. And let's figure out which ratio we're going to use. So let's start with sine. Sine of 65 degrees, opposite is A, and the hypotenuse is C. So we don't have enough information to use the sine ratio. Let's try the cosine ratio. Cosine of 65 degrees is equal to adjacent. So adjacent is 25, and hypotenuse is C. All right, but we are trying to determine side A. So this one doesn't really help us either. So let's try tan of 65 degrees, which is opposite. So opposite is A, and adjacent is 25. All right, so here we would have to use our tan ratio to figure out A. All right, so again, I'm just going to cross this one out and this one out, and we're going to use the tan ratio to figure out side A. So you can just use cross multiplication here. So A will be equal to tan 65 multiplied by 25. So let's use our chart to figure out tan of 65, or you can use your calculator. You would just type in tan 65. So using the chart, here is 65, and tan of 65 is 2.1445. Okay, so 2.1445 multiplied by 25 gives us side A. And that gives me 53.6125 centimeters for side A. All right, let's take a look at this example. So here we have our triangle. We're given one side is 15 decimeters. We're given an angle of 34 degrees, and we need to figure out side Y here, which is the hypotenuse. All right, so let's start by writing out our SOHCAHTOA. And let's see which ratio we can use. So our sine ratio, sine of 34 degrees is opposite, which is 15, divided by our hypotenuse, which is y. So right away here, we can see that we can use our sine ratio to figure out side y. But I'm just going to write out the other ratios as well. Cosine of 34 degrees is adjacent. We're not given anything adjacent, so I'm just going to have to put adjacent over y. So we can see here, not enough information to use our cosine of 34 degrees. And last would be tan of 34 degrees, which is opposite. Opposite is 15. And adjacent, which we are not given, and which we are not trying to find. All right, so we can't use this one, we can't use this one. We will be using sine of 34. You can use your calculator to determine sine of 34. Just type in sine 34, or you can use the chart. All right, so 34 degrees, right here is 34 degrees, and sine, the value is 0.5592. And again, you can just use your calculator as well. So 0.5592 is equal to 15 over y. All right, and now we just have to figure out y. So you can just use cross multiplication. Imagine that this is over 1. So 1 times 15 is 15 divided by 0.5592. So y is equal to 15 divided by 0.5592. And that gives me an answer of 26.82 decimeters for the length of side Y.